Guys, welcome to my YouTube channel. Today I'm going to talk about the ECG like I promised previously. In my previous video, I talked about how to perform a 12-lead ECG, and I also talked about the cardiac conduction system of the heart. If you have gone through those videos, they will enhance your understanding of what I'm now going to talk about, which is called the ECG. ECG, ECG, it's an abbreviation which stands for electrocardiography. So electrocardiograph, it's a graphical presentation of the electroconduction system of the heart, which is shown in waves. So it has got some boxes, some bigger boxes and smaller boxes, which shows distance and time. So this I've just drawn a rough sketch so that I'll be able to explain about the boxes. There are some smaller boxes. For example, this one is a smaller box. One smaller box of the graph that is used to represent an ECG is 0.04 seconds. And there is a bigger box which consists of 5 of these smaller boxes, like 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, which gives us the bigger box gives us 0.2 seconds in time. So these help us to read through our ECG as I'm going to explain. So like it's if our P wave covers one box, we'll say it is covered 0.2 seconds. 0.04 seconds. If it covers 2 boxes, we'll say 0.08. 3 boxes, 0.12 seconds. And 5 boxes becomes 0.2 seconds. And our paper runs at 25 millimeters per second, or it is calibrated as 10 millimeters per 1 millivolt. Okay, from there now I want to talk about the ECG and its components. The normal ECG. The normal ECG tracing usually looks like this diagram I have drawn there. And this diagram, it consists of waves. Like the first wave is known as the P wave. Let me use this color. The first wave is known as the P wave, followed by the Q wave, the R wave, the S wave, and the T wave. So the P wave is this upward deviation, or which represents atrial depolarization. The P wave represents atrial depolarization or contraction, and this or depolarization, and this occurs in response to the firing of the sinoatrial node. And from the P wave, the distance between the P wave and the beginning of T wave is called the PR segment, which is time that is taken for the wave of contraction to move from the atria to the ventricle, where and the beginning of the QRS complex. We also have what we call the PR interval. PR interval is distance between the beginning of the P wave to the beginning of the Q wave. This is called the PR interval. And it represents the time that is taken between atrial depolarization and the beginning of ventricular depolarization. And under normal circumstances, it's 0.12 to 0.2 seconds, which is represented by 3 to 5 small squares or boxes. Also, this P under normal circumstances, it's 0.06 to 0.12 seconds. And we also have our QRS complex. The QRS complex represents ventricular depolarization or contraction of the ventricles, and usually it is 0.06 to 0.12 seconds under normal circumstances. And we also have got our ST segment, which is the end of ventricular depolarization to the beginning of ventricular repolarization or beginning of T wave, which is called ST segment. And under normal circumstance, it's just an isoelectric line. We also have got a QT interval. Our QT interval is the period from the beginning of the QRS complex to the end of the T wave. And we also have this T wave which follows the QRS complex, and it usually represents repolarization of the ventricles. Atrial repolarization is not normally present or visible on the ECG because it is masked by the QRS complex. It occurs during ventricular depolarization, therefore it's not visible. And sometimes you can find a U wave on an ECG. It's not significant. Its absence is not significant, and there's nothing more has been studied about it. So, like I said, a normal ECG always has a P wave. A P wave shows that the wave of contraction was initiated by the sinoatrial node, and it represents atrial contraction. And each P wave is followed by a QRS complex and a T wave. And also the heart rate for a normal ECG, which begins from the sinoatrial node to the and propagated to the AV node through his band rod to Purkinje fibers. Under normal circumstances, it produces a heart rate between 60 to 100 beats per minute. And if there is a P wave and the heart rate is between 60 to 100 beats per minute, we call that a normal sinus rhythm. And if there is a P wave and our heart rate is less than 60 beats per minute, we call it sinus bradycardia. And if our wave of conduction starts in the sinoatrial node, that is, we have got presence of a P wave, and the heart rate is greater than 100 beats per minute, we call it sinus tachycardia. So a normal ECG is a P wave followed by a QRS complex and a T wave, and it's a cycle which continues, and this occurs during one heartbeat. So on an ECG paper, we can also determine the rhythm of the heart to see whether the rhythm is regular or irregular. So using an ECG, how you can show whether the rhythm is regular or irregular is what I'm going to talk about now. Let's take, for example, I can't find my paper. Okay, let's take, for example, this paper. You can see this this upward deviation shows R wave, and this one is an R wave, this R wave, this R wave, this R wave. So our ECG paper normally looks like this, and if you want to find out if the rhythm is regular or irregular, you use a piece of paper which is plain like this one, and let's say this is the paper. You measure the difference from the distance from one R to the next R, and you put a sign to show where one R begins and where the next R begins. For example, like this one, we can see these R's. I'll take my paper there, then I'll put a mark where the first R is and a mark on the next R. So I'll use this paper to check to see if the preceding R's have got the same distance in between, like this, and you see there is similar distance from this one to this one and the next R to the next one, and I'll check the next one again if the difference is the same, the next one again the difference is the same. So we've got a regular rhythm. So if you are on a monitor, you can also use what we call calipers. They can also help you to find out if the rhythm is regular. So if the rhythm is irregular and you want to calculate heart rate of a patient using the provided ECG, you just go to your ECG. For example, let's say this is my ECG. I'm going to draw the next. Let's say this is P, Q, R, S, and T. Right. So you just take your ECG, you count the number of large boxes between this R and this R. Then the number of large boxes, you divide that by 300 to get the heart rate of the patient. For example, let's say I've got 5 large boxes between this R and that R. I'm going to divide 5 into 300, which will show that the heart rate is 60 beats per minute. So that's the other way of calculating heart rate, using when the rhythm is regular on a patient, using the ECG paper. And if there are 2 large boxes, it means you are going to divide 2 into 300 and your heart rate will be 150 beats per minute. If there's 1 large box, it means you're also going to divide 300 by 1 and your heart rate will be 300 beats per minute. If there are 3, you are going to divide 300 by 3 and heart rate will be 100 beats per minute. And if the heart rate is not regular, that is, the distance from one R to another is not similar, it means you are not going to use the method of calculating the big boxes from one R to another to calculate the heart rate of a patient using the ECG strip. So what you do is you take a 10-second strip and you calculate the number of R's on that 10-second strip. Then you multiply that by 6. For example, I said a 10-second strip. 10 seconds times 6, you get 60 seconds, which is equivalent to 1 minute. So you calculate the number of R's in the 10-second strip and you multiply that by 10 and you get the heart rate of a patient using the ECG tracing. So like I said, a normal ECG has got a P wave, and the P wave is followed by QRS complex and the T wave. And also the time should also be put into consideration, the number of boxes as well as the time taken and the rhythm of the patient, and the heart rate as well is also put into consideration to determine whether the ECG is normal or not. So I hope you have understood my channel about a normal ECG and its components of Q, R, S, T, and the intervals, the time intervals I had also incorporated in my video. So tune in, guys, tomorrow. Sorry, not tomorrow. Next time I'll talk about other ECG patterns which are not normal. Today I've talked about the normal ECG. Next time I'll talk about the abnormal ECGs and how they present and how they are treated. So please, guys, like and subscribe to my channel so that I'll be able to give you more of these videos and try to explain as much as possible. Thank you.